The first step, if you're given a series and you're asked whether it converges or diverges, the first step on this flowchart is to see if you have a recognizable form, either a geometric series or a p-series. If you don't have one of those, then step 2 is to move over to the divergence test. We're going to look at those details for the divergence test here. So what you need to do with the divergence test is to take the limit as n goes to infinity. So that probably looks a little bit familiar to you. And if we go back, that's actually the definition for determining whether a sequence converges or not. So for a sequence, if we take the limit and the limit exists and it's finite, then we know our sequence converges. This is going to be a little bit different if it's a series. All right, so if I take that limit and it is not equal to 0, or it goes to infinity, or it does not exist, then my series diverges. Okay, I want to take a look at this criteria. So this limit is not equal to 0. So if I have a sequence, and I'll call that sequence A sub n, I can start writing out the terms, A1, comma, A2, comma, A3, right, and so on. To change that into a series, I'll stick a summation sign out in front of it, and then it becomes A1 plus A2 plus A3, and keeps going. All right, suppose that I have a convergent sequence, and I know that the limit as n goes to infinity of my sequence is equal to 2. What that means is I can come up here and I can say that this series is approximately equal to 2 plus 2 plus 2, and so on. So I can replace all of those terms with a 2, get an approximation for what it adds up to. And I think it's probably pretty clear that this is going to infinity and it diverges. So that's kind of the rationale behind this criteria. If the limit's not 0, it definitely diverges. Now, on the flip side, if the limit is 0, we don't know anything at all. This is a go fish situation. So you cannot get convergence out of that. Sometimes if the limit is 0, sometimes the series will converge, sometimes it'll diverge, we just don't know. All right, so let's take a look at some of these problems. Number 5, I'm going to apply the limit as n goes to infinity of n squared plus 7 over n. And if it's been a bit since you've done these limits at infinity, I want to look at the biggest power term in the numerator and denominator. So I have n squared over n, which is equal to n. So essentially, I'm looking at the limit as n goes to infinity of n. That is going to go to infinity. And so I know that my series diverges by dt. All right, number 6, I have the series n equals 1 to infinity of 1 over n. I have the limit as n goes to infinity of 1 over n, which equals 0. Well, that's bad news. I don't know anything. So I would write down that this is inconclusive by dt. You only need to write that if you were specifically directed to use the divergence test to see what you could find out about that series. Otherwise, you don't need to write anything down if that limit is 0. Right, and then I have this series n equals 1 to infinity of 2 to the n over 3n plus 1. So again, I'll do the limit. So the limit is n goes to infinity of 2n over 3n plus 1. So my highest power terms are the 2n and the 3n. So this limit is equal to 2/3, and that is not equal to 0. So this diverges by dt. Now, I want to point something out here in terms of writing this up. Technically, your write-up includes all of this. This is why I leave a little bit of space over here. Then I don't have to rewrite this series down. I can just already use the existing series here, write diverges by dt, put a box around it, and then show my work over here. It's the same thing with number 5. I just want to stick a box around that as my conclusion. Okay, so the nice thing about the divergence test is that you can kind of eyeball it. You don't have to even write anything down. If you don't have a p-series or a geometric series, you can kind of take a look at that series and eyeball it. And if the limit isn't 0, great, write it down, you're done. If the limit is 0, don't write anything down, just move on to one of these other tests. We're going to take a look at one of those tests next.